Good morning, Geometry Honor students. So Mr. Chen again. So this one and just another extension section. So 11, chapter 11. Again, this one is not even mentoring from the Big Idea textbook. So it's just additional sections that I just want to point out to go over with all the students here. So Heron's and Brahmagupta's formula. Subjective, find the area of a triangle and quadrilateral using the H or the B formula. So H formula, which is the Heron's formula, and B formula, which is the Brahmagupta's formula. So Heron's formula, here we go. So it's the area of a triangle, so that equals the square root of the quantity of the product, S, which is the semi-perimeter, times the quantity of S minus A, so A, which is the shortest leg of the triangle, and then times the quantity of S minus B, so B, which is the medium size of the triangle, and then the quantity S minus C, so C, which is the longest leg of the triangle. Again, semi-perimeter, the way to find it, it's A plus B plus C, and then it's all over 2. And then the Brahmagupta's formula, it's the area of the quadrilateral, the inscribed quadrilateral inside a circle. So it's being bounded with those vertices, so you can say that point A, point B. Okay, so point A, I would like to use this one because that's facing to this segment. So started with point A, and then over here, point B, point C, and then point D. So this one is being bounded with all those vertices, so segment A, B, C, D. So it's a square root of the quantity, so S minus A, S minus B, S minus C, S minus D. And then where S is the semi-perimeter of this quadrilateral. So A plus B plus C plus D divided by 2. Okay, so now let's take a look at that. Find the area of the triangle with A equals 5, B equals 7, C equals 8. So this one, definitely we can apply that the Heron's formula. So A, which is 5, the shortest leg. So B, the medium leg, 7, and the longest leg, 8. So using that, the Heron's formula, so which is getting the semi-perimeter first. So A plus B plus C all over 2. So we got 5 plus 7 plus 8 all over 2. So 5 plus 7, that's 12, plus 8, which is 20 over 2, so that's 10. So, and according to the formula there, and which is considered S times S minus A, S minus B, S minus C. Okay, so we got 10, 10 minus 5, which is 5, 10 minus 7, then that'd be 3, 10 minus 8, then that'd be 2. So 10 times 5, 50, 3 times 2, 6, 50 times 6, then that would be 300. And then using that, the perfect square, the simplification, the factor tree. So what we got, it's considered 10 root 3 for the area of this triangle. So there's no need to find the height, and there's no need to use that 1/2 times base times the height. And then here's another one, find the area of the inscribed quadrilateral with A equals 3, B equals 5, C equals 9, and D equals 5. So similar to what we just did, so find the semi-perimeter first. So 3 plus 5 plus 9 plus 5, again, divided by 2. So 3 plus 5, that's 8 plus 9, which is 17, 17 plus 5, which is what, 22 divided by 2, so it's 11. Okay, so that's a semi-perimeter. And now let's use that the Brahmagupta's formula. So which is considered area of the quadrilateral equals square root of S minus A, S minus B, S minus C, S minus D, and then the product of all those quantity. So square root of, so 11 minus 3, which is 8, times 11 minus 5, 6, 11 minus 9, times 2, 11 minus 5, times 6. So what we found here, so this one, it's 48 times 2, 96. 96 times 6, so 6 times 6, 36, 9 times 6, 54, plus 3, 57, so 576. And also think about the way to put in the factor tree. So 6 times 6, that's 36. So that's considered a perfect square number. 8 times 2, that's 16. So this one can be written as, okay, like that. So 2 perfect square numbers. So what we found, it's 6 times 4. So which is what? 24. So 576. So square root of that, it's a perfect square number. So which is 24. And the unit, you can put in that unit square or square unit. This one as well, the previous one, square unit. Okay, so now let's see what else that we have. So find the area of the pentagon to the nearest tenth. Okay, so this inscribed pentagon. So you might be wondering, this one, it's not a regular pentagon. So what we can do, we can always set up the auxiliary line segment. So once we find out that the hypotenuse here, because this one is a right triangle, so we can use the Heron's formula. And also for the rest of the quadrilateral, this one we can use the Brahmagupta's formula. So using the Pythagorean theorem, this one is 4, 5. So 16 plus 25. So then that would be what? Let's say this one is c squared. So 16 plus 25, which is 41. Okay, because this one is the hypotenuse. So using the Pythagorean theorem. So 41, so that equals c squared. So that means c equals square root of 41. Okay, and then using that, the Heron's formula. So finding the semi-perimeter of this triangle. So which is 4 plus 5 plus root 41. It's not a nice number. Okay, so this one just divided by 2. So it's 9 plus root 41 over 2. You don't want to round things up yet, so just leave it as the way it is with the radical. And then to set up with the area, the triangle. So S, which is what? 9 plus root 41 over 2. I mean, you can estimate it to find out what happened with the rest of those number. And then plug in the number. So S, using that the same number, subtract 4, subtract 5, and then subtract C. Okay, so you'll get that, the differences. So this one, let me just write it down here. So I just need to get more space for this one. Again, this one you probably want to use a calculator. So after you set it up, because it's a lot of irrational number. So area for the triangle, so square root of the semi-perimeter. So 9 plus root 41 over 2 times. So 9 plus root 41 over 2 minus 4 times 9 plus root 41 over 2 minus 5, and then 9 plus root 41 over 2 minus root 41. Okay, so just calculate that and put it into the calculator and find out what that is. And then the other one is the area of the quadrilateral, the inscribed quadrilateral. Again, that one using the Brahmagupta's formula. So C is root 41. So find the semi-perimeter, 5 plus 5 plus 3, and then plus root 41 divided by 2. So that's another semi-perimeter. And then using that, the Brahmagupta's formula, area, which is S minus A. So this whole number, minus 3, and then S minus 5. S minus 5 can square that number if you want. And then S minus C, which is root 41. Okay, so just calculate that once you come up with the area for this one and the area of a triangle. All you need to do, just combine those two areas together. So A1 plus A2, then that'll be the total area. So again, so irrational number, you can always put into the calculator, but make sure that you need to put in the parentheses with the grouping. Without the parentheses, that would be a typo, okay? And now let's see what else that we have. Okay, so that's it. So thank you for watching the video today. Again, the brand new formulas that you need to know. So again, for Unit 11, there are tons and tons of formulas that you need to know. Lateral area, surface area, volume for the three-dimensional figure, and also the inscribed, quadrilateral, and also the triangle with all three segments given. So we can use the special formula to get those areas. Alright, so I'll see you guys next time. Thank you for watching it.